Good morning, students. This is Murthy, sir. Today, you will learn about the first concept in chemistry, acids, bases, and salts. First, we will go through the physical properties of acids and bases. Let us see the differences in the physical properties of acids and bases. Acids turn blue litmus paper red. Bases turn red litmus paper blue. Acids give off hydrogen ions in water. Bases give off hydroxide ions in water. Acids generally taste sour and bases taste bitter. Bases are usually soapy in nature. Acids corrode active metals. Bases denature proteins. Acids have a pH less than 7. Bases have a pH greater than 7. Now let us see the similar properties of acids and bases. When you dissolve an acid or base in water, it makes ions. This makes the water conduct electricity better. The stronger the acid or base, the more ions are produced, so the conductivity of the solution increases. They can both conduct electricity. When an acid reacts with a base, a salt is formed. This is called neutralization process. They both can carry and share ions. In this table, you can observe some examples of strong acids and bases. Hydrochloric acid, sulfuric acid, nitric acid, or examples of strong acids. Sodium hydroxide, potassium hydroxide, calcium hydroxide, or examples of strong bases. In this table, you can see some examples of weak acids and weak bases. Acetic acid, carbonic acid, formic acid are examples of weak acids. Ammonia, sodium bicarbonate are examples of weak bases. Now let us see the chemical properties of acids and bases. In this experiment, dilute hydrochloric acid reacts with zinc granules to form zinc chloride and hydrogen gas is liberated. When hydrogen gas is liberated from delivery tube by keeping a burning matchstick, we will get a pop sound. Sodium hydroxide reacts with zinc granules to form sodium zincate and hydrogen gas is liberated. Sodium carbonate reacts with hydrochloric acid to form sodium chloride, water, and CO2. Sodium bicarbonate reacts with hydrochloric acid to form sodium chloride, water, and carbon dioxide. The IUPAC name of sodium bicarbonate is sodium hydrogen carbonate. It is commonly known as baking soda. During a neutralization reaction, an acid and a base react to produce a salt and water. Hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Sulfuric acid reacts with sodium hydroxide to form sodium sulfate and water. Dilute hydrochloric acid reacts with cupric oxide, a metallic oxide, to form copper chloride and water. This is a double displacement reaction. Here you can see the crisscross method of valencies of cupric oxide. Copper has two valencies, Cu plus 1, Cu plus 2. Cu plus 2 is called cupric. Higher valency is called cupric. Calcium hydroxide, a strong base, reacts with a non-metallic oxide, carbon dioxide, to form a white precipitate, calcium carbonate, and water. When calcium hydroxide reacts with CO2, a white precipitate of calcium carbonate settles at the bottom of the test tube. You can see here the white precipitate at the bottom of the test tube. Whitewashing walls. Calcium hydroxide reacts slowly with carbon dioxide and air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the walls. This is a practical application of this chemical reaction. Hydrochloric acid is a strong electrolyte and dissociates completely in aqueous solution. The solution contains free mobile ions which allow electric current to pass through it. Hence, hydrochloric acid is a good conductor of electricity. Now, let us learn about an experiment which proves that dilute hydrochloric acid conducts electricity. Take one glass beaker and place one rubber cork at the bottom of the beaker. Place 2 nails, iron nails, on the rubber cork. Now take dilute hydrochloric acid solution to almost half level of the beaker. Now connect the nails with the help of wires to a 6-volt battery and a bulb. When current passes through the wire, dilute HCl conducts electricity as it dissociates into hydronium and chloride ions. In this experiment, hydronium ions are formed when hydrogen ions associate with some water molecules. H3O plus is called hydronium ion. Aqueous solution of acid conducts electricity because it has a higher concentration of hydronium ions to carry electricity. When acid is diluted, the concentration of hydronium ions increases as hydrogen ions present in acid react with water to form more hydronium ions. In this electrolytic cell, when dilute HCl conducts electricity, the bulb glows, and it is proved that dilute solutions of acids, they conduct electricity. Sulfuric acid reacts with sodium chloride to form sodium sulfate, and hydrogen chloride gas is liberated in this chemical process. In this experiment, the hydrogen chloride gas which is liberated from the test tube will not turn blue litmus paper red in color. The reason is solid sodium chloride reacts with concentrated sulfuric acid and forms dry hydrogen chloride gas. In this experiment, if we take moist or wet litmus paper, it turns red in color. The reason is for the formation of ions, water is important. So in dry condition, formation of ions is not possible. The strength of acids is due to the formation of hydronium ions.